Okay, today I'm going to go over the key for Quiz 6 for Math 21A Section D01. The first question says, calculate the derivative with respect to theta of cosecant inverse of theta. Okay, so the first thing we need to remember is what the rule about the derivative of inverse functions is. And that rule says that the derivative of f inverse of x with respect to x is equal to 1 over the derivative of the original function composed with the inverse function of x. So if we apply this to our problem here, we're going to say that f inverse of theta is cosecant inverse of theta. So f of theta is then cosecant of theta. And we know then f prime of theta is negative cosecant theta cotangent theta. So now if we apply our rule, we know that the derivative with respect to theta of cosecant inverse theta is 1 over negative cosecant cotangent. Now rather than theta though, I need to compose with my inverse function, cosecant inverse. So I put that in to both of these functions. Now I just need to solve and simplify. Now cosecant of cosecant inverse, those obviously just compose to be theta. So I have 1 over negative theta cotangent of cosecant inverse of theta. Now we can use a triangle to see what exactly cosecant inverse, what the cotangent of cosecant inverse is. So if we say that x equals cosecant inverse of theta, then theta is cosecant of x. Now if we simplify that, we know that theta equals 1 over the sine of x, because that's what cosecant is defined as. And then we know that sine of x is 1 over theta, if I just invert both sides. So now if x is, in this case, the angle, then I know that rather than that the sine of x is 1 over theta. So opposite over hypotenuse, right? So that means this is 1 and this is theta. Then I can solve for this other side. I know this is theta squared minus 1, because I know that this side squared plus this side squared has to be this side squared. So now I can just go ahead and solve. I have 1 over negative theta. Now the cotangent of cosecant inverse theta, that's just cotangent of x. Now the cotangent of x is, well, tangent is sine over cosine, so cotangent is cosine over sine. So cosine over sine is the adjacent over the opposite. So it's the square root of theta squared minus 1 over 1, which is just the square root of theta squared minus 1. Okay, the second problem asks us to find the normal line to the curve y cubed plus 3x squared y plus x squared equals 0 at the point 2, 1. Now in order to find the normal line, we first need to find the derivative of the line tangent to the curve at this point. And in order to do that, I find dy dx. The way to do this is to differentiate the function, the curve. So I'm going to get 3y squared and times dy dx by the chain rule, right? Plus 3x squared dy dx. Now this is a product rule. I have a function times another function. So I add 6xy. So this first one is the derivative, is just this function times the derivative of y, and the second one is the derivative of this function times y. And now I take the derivative of x squared, and I get 2x, and obviously the derivative of 0 is just 0. Now I can simplify this, and I will get that dy dx times, I'm factoring these out, 3x squared plus 3y squared. I'm subtracting these to the other side, minus 6xy minus 2x. So now I have the derivative of y times the derivative of x times the quantity 3x squared plus 3y squared is equal to negative 6xy minus 2x. I can divide both sides by 3x squared plus 3y squared, and I get the derivative with respect to x of y is negative 6xy minus 2x all over 3x squared plus 3y squared. Now I need to evaluate this at our point, 2, negative 1. When I do so, I'll get that negative 6 times 2 times negative 1 minus 2 times 2 all over 3 times 2 squared plus 3 times negative 1 squared. Now this simplifies to 8 over 15. Now notice though, this is the slope of the line that is tangent to the curve. I want the slope of the line that is normal to the curve. If you think of a curve, right, the line that's normal to it, or excuse me, tangent to it, goes like this. The line that's normal to it is the line that's perpendicular to that tangent line. So that means that the slope of my normal curve, my normal line, excuse me, is just the negative reciprocal of this slope. So m is negative 15/8. Okay, now I just need to use my point slope formula. See, I have y minus a negative 1 because of my point here is equal to negative 15/8 times x minus 2. This simplifies to y is equal to negative 15/8 x minus 2 minus 1. And that is the equation of the normal line.